solutions for our free stoichiometry worksheet available at www.zenofchemistry.com. Let's start with question number 1. Calculate the mass of precipitate produced if 5 grams of barium chloride is reacted with excess sodium sulfate. And we've got our equation here. So the first thing I do in stoichiometry questions is to ascertain what is our starting point and what is our finishing point. Now, what I mean by that is we're told that we have 5 grams of barium chloride. So what I do is I'm going to put that under our barium chloride. M equals 5.00 grams. Okay, and that's what I would call our starting point. Okay, then I'm going to look at the rest of the question. Calculate the mass of precipitate. Now you need to realize that that's what it's asking for. Our precipitate is our solid. Okay, so it's asking for the mass of barium sulfate. So I'm going to go M equals question mark, and that's what I would consider to be our finishing point. Okay, and you know that you've got a clear starting point and a clear finishing point. It's talking about the fact that we've got excess sodium sulfate. So this doesn't really enter into the stoichiometry problem at all. There'll be some later questions that deal with an excess limiting reagent and excess reagent. So we'll get to them in a minute. So essentially we can start by calculating number of moles. We can't work from mass to mass. Stoichiometry always works through number of moles and the stoichiometric ratio. So if we calculate our molar mass of barium chloride, capital M, okay, we've got our molar mass of barium, which is 137.3 plus 2 times 35.5. 35.5 is our molar mass of chloride. So if we calculate that out, we get 208.3 grams per mole. Okay, we've got mass, we've got molar mass. Let's calculate our number of moles. N equals little m on big M, which is 5.00 divided by 208.3. If we throw that in the calculator, we get 0.0240 mole. Okay, so we've calculated our number of moles for our barium chloride. As I mentioned, we always work through number of moles. And what I mean by that is we look at the ratio of barium chloride from our starting point to our finishing point. And you can see, well, you can't see, but what is implied behind those is that we have a 1 and a 1 there. They're invisible in the equation, but this is a balanced equation. So we have a 1-to-1 ratio. Therefore, the number of moles of barium sulfate is equal to the number of moles of barium chloride. Okay, so it is equal to this number here that we've just calculated. Okay, if we want to know the mass of barium sulfate, we need to calculate the molar mass. Okay, so molar mass of barium again is 137.3 plus our sulfur, which is 32.1 plus 16 for oxygen times 4, because we've got 4 of them. The molar mass there, if we throw it into calculator, is 233.4 grams per mole. Okay, so to calculate our M equals N times M. Okay, and so that will be 0.0240 times 233.4 is equal to 5.60 grams. Okay, so we've got in our finishing here, our finishing result is 5.660. I haven't written 5.6. Okay, we started off with 3 significant figures, 1, 2, 3, and so we finish with 1, 2, 3 significant figures. If you are struggling to work out what equation to use for which one, I recommend you have a look at our video on how to use equation triangles.